On a quiet night, the earth was turning, as it always does, wrapped in a blanket of familiar silence. Yet far away across gulfs of darkness, so immense the mind can hardly grasp them, something happened. A flicker, a pulse, a whisper. It did not come from any star we know, nor from any planet we can see. It was not born of our sun, nor of the steady chatter of human machines. It came instead from the deep void, a thin, fleeting murmur, caught by the great mechanical ears of our species, and once heard it refused to let go of the imagination. Imagine this. You are listening to static on an old radio, a dull hiss of white noise, meaningless and endless. Then suddenly, among the monotony, a sharp and startling sound cuts through. For a moment you are sure someone is there. Someone has spoken to you, but before you can even take a breath, it vanishes. That is what astronomers faced the first time they detected what are now called fast radio bursts, or FRBs. Each one arrives without warning, flashes for less than the blink of an eye, and yet unleashes a torrent of energy equal to what our sun radiates in days, sometimes weeks. All of that compressed into a fraction of a second. It is as if the universe leaned close to our ear, whispered something urgent, and then vanished back into silence. The scale of it is staggering. To put it into perspective, if you were standing on the moon and switched on every radio transmitter on Earth simultaneously, the combined signal still would not equal the raw power of some of these bursts. And yet for all their energy, FRBs are fragile by the time they reach us. They travel across millions or even billions of light years, weaving through clouds of gas, bending around galaxies, scattering through magnetic fields, until finally a ghost of their original force brushes against our antennas here on this small blue planet. It is like hearing the last faint echo of a shout shouted into the Grand Canyon long before you were born. When the first FRBs were reported, the reaction within the scientific community was a strange blend of disbelief, excitement, and skepticism. Some wondered if it was a fluke of the instruments, a malfunction of the detectors, or even interference from something as mundane as a microwave oven in the observatory's break room. But as more detections followed and from different telescopes across the globe, the reality became undeniable. The signals were real, and they were not of Earth. Whatever was happening, it was happening out there. That realization alone was enough to spark a fire of speculation. If these bursts came from beyond our planet, then what was their source? Natural events like the violent collapse of stars into neutron remnants, or the grinding tension of magnetic fields snapping in cosmic storms, could explain their sheer power. But the neatness, the abrupt clarity of the bursts made some wonder about another possibility. Could they be artificial? Could they be messages? After all, when humans first invented radio, one of our earliest ideas was to use it to reach beyond ourselves. We beamed signals skyward, hoping they might be intercepted by someone somewhere. Could it be that what we had hoped to send, we were now beginning to receive? The thought is intoxicating, but also unsettling. If it is a message, then it is one that comes without context, without explanation, without even repetition. It is a word whispered in the dark, but never spoken again. How does one reply to that? Is it meant for us at all? Or have we only stumbled upon a conversation so far above our scale that we cannot even pass the grammar? These are the kinds of questions that sit at the heart of FRBs, twisting the mind between awe and unease. Even the silence that follows each burst feels heavy, because if it is only the universe itself, a natural mechanism we do not yet understand, then the mystery lies in nature's endless inventiveness. But if it is something more, if it is in fact intentional, then we are eavesdropping on something extraordinary, perhaps even terrifying. The uncertainty is what makes it so haunting. Take a moment and imagine that first night, the astronomers poring over their data. Numbers scatter across a screen, most of them dull, predictable. And then a spike. A signal far brighter and sharper than anything else, as if the cosmos had tapped them on the shoulder. They probably felt a mix of dread and wonder, the same way you might feel if you were walking alone at night and suddenly heard your name whispered in the darkness. The burst itself lasts less than a millisecond, but the questions it raises linger for decades. Why here? Why now? Why like this? If it is random, then the universe is playing dice with forces that dwarf our imagination. If it is deliberate, then the very fabric of our place in existence shifts. We are no longer alone in the dark, no longer the only ones with a voice. We are instead listeners waiting at the edge of a conversation that might never include us. And here is the most paradoxical part: the more we detect, the more mysterious they become. Some FRBs appear once and vanish forever, never to repeat. Others return again and again, though, with no clear rhythm, like someone knocking at your door but never keeping time. This mix of the fleeting and the persistent only deepens the riddle. They are both stable and chaotic, reliable and unpredictable, as if the universe is teasing us, hinting at a pattern, but refusing to reveal the key. Science thrives on patterns, on repetition, on order that can be measured. But FRBs dance on the edge of that order, reminding us how much remains unseen. They are a challenge not just to our instruments, but to our imagination. Because whether they come from collapsing stars or civilizations beyond our reach, their very existence expands the limits of what we thought possible. Pause for a moment and let that sink in. Somewhere billions of light years away, something happened with such ferocity that its dying echo is only now reaching us. Think of the scale of that distance. By the time the burst arrived here, whole galaxies may have risen and fallen, entire species may have emerged and vanished. The source itself may already be gone extinguished, long before Earth even cooled enough to grow forests. What we are hearing then is less a live conversation than a time capsule, a relic of an event that predates us by unthinkable ages. And yet when that fragile signal finally brushes against our detectors, it is as if the universe itself sighs into our ears. The void is not empty, it is alive with sudden cries, each one a mystery packaged in light we cannot see but can somehow hear. If the universe can whisper to us, the question becomes whether we can learn to truly listen. Our ears are built for whispers of air, tiny ripples moving through our atmosphere. They are finely tuned for voices, for music, for the rustle of leaves, but they are deaf to the grand chorus of the cosmos. The universe hums with frequencies, sings in waves, roars in invisible storms, and yet with nothing more than our bodies we would never know. To hear the sky, to really listen to its hidden songs, humanity had to build new ears, vast instruments that do not vibrate with sound, but instead drink in the invisible tides of radio waves pouring endlessly through space. These were not ears of flesh, but ears of steel, copper, and wire. The birth of these cosmic ears began almost accidentally. In the early 1932nd, a young engineer named Karl Jansky was tasked with solving a mundane problem for the Bell Telephone Company. Long-distance radio telephone lines were plagued by mysterious static, and Jansky's job was to find its source. He built a massive rotating antenna in a New Jersey field, a strange contraption that looked like something between a carousel and a spiderweb of wires. Day after day, he recorded the noise it captured. Some interference came from thunderstorms, both nearby and distant. But there was another pattern, quieter, steadier, and puzzling. It repeated not with the rhythm of a day, but with a slightly longer cycle, one that matched the sidereal day, the time it takes for Earth to rotate once relative to the stars rather than the Sunday. What Jansky had stumbled upon was astonishing. His antenna was picking up radio waves from the Milky Way itself. The universe was broadcasting, and he had just tuned in. In that moment, a new kind of astronomy was born, no longer confined to visible light, no longer limited to what the human eye and its glass extensions could see. Astronomers now had access to an entirely different spectrum, one that revealed the hidden pulse of the cosmos. At first, this revelation was met with a kind of stunned quiet. Jansky's work was important, but it was not what his company had asked for. Bell Labs thanked him, then moved on to more practical matters. But a seed had been planted, and others soon saw the potential. Among them was Grote Reber, a radio engineer and amateur astronomer who decided on his own to push further. In his backyard in Illinois, he constructed what would become the world's first true radio telescope, a dish-shaped reflector aimed at the heavens. Where Jansky's antenna had been improvised and built for utility, Reber's creation was deliberate, designed to map the sky in radio frequencies. Through this homemade device, Reber confirmed Jansky's discovery and went further, producing the first radio maps of the Milky Way. These images revealed a galaxy far different from what telescopes of glass and light had shown. Hidden behind veils of dust, stars, and cosmic gas, entire structures emerged in radio, as if a second universe had been layered beneath the first, waiting for us to notice. It was a revolution not just in technology, but in perception. The cosmos was no longer silent, and humanity was no longer blind to its unseen dimensions. Consider how transformative this was. For millennia, the night sky had been interpreted solely by what could be seen. Our myths, our calendars, our earliest sciences all built on visible light. The stars above seemed eternal, unchanging, almost serene. But when we learned to listen with radio ears, the illusion shattered. We discovered that space was anything but still. It was alive with storms of radiation, with jets of matter hurtling from quasars, with pulsars ticking like cosmic metronomes. What the eye could not see, the ear of radio astronomy revealed in astonishing clarity. This was more than science. It was a shift in human imagination. Suddenly we were like people who had been deaf their whole lives, waking to find the world filled with music. Every new frequency brought fresh revelations. The sun, for instance, was no longer a glowing ball, observed only in visible light, but also a crackling source of radio emissions, its activity mapped in a new way. Galaxies were no longer pinpoints of light, but roaring furnaces of radiation. Even the quiet spaces between stars buzzed with a faint background, a glow that hinted at something even larger, the echo of the Big Bang itself. In this sense, the invention of cosmic ears did more than extend science, it expanded the boundaries of human perception. We had been blind to most of reality, lulled by the narrow band of visible light, mistaking it for the whole. But with each new ear we constructed, the universe grew larger and stranger. Imagine lifting a curtain that has always hung across your vision, revealing a theater far bigger and more complex than you had ever imagined. That is what radio astronomy gave us. The instruments themselves also evolved in ways that reflected the ambition of their makers. From Jansky's rotating antenna in a field, to Reber's modest backyard dish, to sprawling arrays of dishes spread across deserts and plains, the scale of our ears grew with our curiosity. The very large array in New Mexico, with its great arms of dishes stretching across the landscape, resembles a giant instrument tuned to the voice of the cosmos. When these dishes point skyward in unison, they form an ear vast enough to capture whispers from billions of light years away. With such tools, the universe began to speak more clearly. Pulsars discovered in the 1962nd first appeared as strange regular signals so precise that astronomers briefly wondered if they might be artificial. Quasars, too, were unveiled by their roaring radio emissions, their brilliance hidden behind distance, but revealed by their invisible songs. Each discovery reinforced the truth that to know the universe we must not only look, but also listen. And yet listening comes with its own puzzles. Signals arrive wrapped in noise, distorted by their journey, and sometimes so strange that we cannot tell if they are natural or something else. The invention of cosmic ears did not bring only clarity. It also invited confusion, because when you open yourself to voices you have never heard before, you must also confront the possibility that some of them will not fit into your understanding. Pause for a moment and imagine the first scientists leaning over their instruments, the hiss of static filling their recordings, then a sudden spike, a strange rhythm, a pattern too sharp to ignore. Their hearts must have raced. They were listening not just to stars, but to phenomena no one had even conceived. It was as if the universe had been speaking forever, but only now had we learned to tune in. This act of tuning in, of extending human senses into realms they were never meant to reach, is one of the defining features of our species. We are not content with what is given. We build extensions of ourselves, mechanical eyes and ears machines, that amplify our presence far beyond our fragile bodies. Each invention redefines what it means to be human, for with each one the universe itself grows more intimate. But intimacy can be unsettling, for the more we hear the stranger the cosmos becomes. And sometimes what our new ears capture is so peculiar, so unexpected, that even the scientists hesitate to believe. What does it mean to hear something too weird to trust? That is where the story of radio astronomy leads us next, into mysteries that challenge not only our instruments but our imagination. They arrive like lightning in the dark, not the kind you see streaking across a stormy sky, but something stranger, sharper, and more elusive. A fast radio burst is over almost before you can name it, a flash of energy, lasting less than 1,000th of a second. Yet in that brief flicker, it unleashes more power than our sun radiates in days, sometimes weeks. Imagine holding out your hand to catch a raindrop, only to find that it carried the force of an ocean wave compressed into its tiny fall. That is what these bursts are: sudden and overwhelming concentrated packets of cosmic fury that vanish before you even know they are there. The first time astronomers stumbled upon one, they weren't even looking for such a thing. Data collected at the Parkes Observatory in Australia in 2007 revealed a spike sharp and undeniable. It came from far beyond our galaxy, so far that by the time it reached us, it had stretched and warped its fingerprint, smeared by the intergalactic medium. The scientists who studied it named it the Lorimer burst, after the researcher who identified it, but the name was just a placeholder for a phenomenon that refused to be explained. At first, no one quite knew what to make of it. Some suspected instrumental error, others thought of terrestrial interference, a quirk of electronics, perhaps even a stray glitch in the data pipeline. But as the years went on, more appeared. Different telescopes, different nights, different patches of sky, and yet always the same signature: a short, furious burst of radio waves from impossibly distant origins. This was no accident, no simple machine noise. Something real and vast was at work. The nature of FRBs defies our instincts about how the universe should behave. Ordinary cosmic events unfold on scales of minutes, hours, or millions of years. Stars are born, they burn, they die, in ways that feel steady compared to the fleeting brevity of an FRB. To fit such enormous power into such a small window of time demands something extreme, something catastrophic, or wildly exotic. Astronomers began to turn over possibilities, each one more dramatic than the last. One of the leading suspects has long been neutron stars, the dense collapsed remnants left behind when massive stars explode. Imagine the core of a star larger than our Sun crushed into a sphere only a dozen miles across. Its matter is so dense that a teaspoon of it would outweigh a mountain. Neutron stars are already bizarre in their own right, with magnetic fields trillions of times stronger than Earth's, and rotations that can whip entire surfaces around dozens or even hundreds of times per second. In such extreme environments, a violent snap of magnetic energy, a so-called magnetar flare, could in theory produce a burst bright enough to match what we see from FRBs. But not every detail fits neatly. Some bursts repeat, sometimes unpredictably, sometimes in curious cycles. A few have been traced back to galaxies that seem ordinary, with no obvious catastrophic event underway. Others appear once and never again, like single notes struck on a piano in an otherwise silent hall. This mix of repeating and non-repeating behavior has forced astronomers to expand their imagination. Could there be multiple causes, some bursts from magnetars, others from processes we do not yet understand? Or could they all be pieces of a puzzle we simply haven't arranged correctly? Black holes too entered the conversation. When matter swirls into their gravitational maws, it can unleash jets of energy that pierce space with violent clarity. Perhaps in certain conditions, these jets or the interactions of binary systems near black holes create FRBs. Another idea suggests collisions, neutron stars slamming into one another, or into black holes generating explosions so fierce they ripple across time and space. Yet the repeating FRBs complicate such scenarios for collisions, are final one-time events, not processes that can echo again and again. And then there are the wilder speculations, the ones that tread the thin line between science and imagination. Some researchers have wondered aloud whether FRBs could be signatures of advanced technologies, perhaps energy beams used to power interstellar travel or communications on scales far beyond our comprehension. After all, when humans first invented radio, we quickly used it to broadcast signals into the sky intentionally or not. Could it be that someone else has done the same, but with tools and energies dwarfing anything we can build? The thought is electrifying not because it is likely, but because it cannot be entirely ruled out. Until the mystery is solved, the possibility lingers. What makes FRBs so maddening is also what makes them so alluring. They are unpredictable, transient, and often impossible to catch in real time. Telescopes must sift through oceans of noise, mountains of static, just to find a single spike, a solitary millisecond of clarity. Yet when they succeed, they capture a signal that has traveled across unimaginable distances, carrying with it clues not only about its origin, but about the medium it passed through. Each FRB is not just an event, but also a probe, a light shining through the cosmic fog, revealing the structure of galaxies, the density of intergalactic plasma, even hints about dark matter. They are mysteries, yes, but also tools, accidental gifts, that help us map the invisible architecture of the universe. Pause here and consider the paradox. In the smallest sliver of time, less than the blink of an eye, lies enough information to rewrite our understanding of cosmic physics. The bursts may be rare, but the universe is vast, and if they occur across billions of galaxies, they may actually be happening all the time. We simply lack enough ears to catch them all. What we call rare may in truth be abundant, and what we call mysterious may someday become familiar. But for now, each new detection feels like a stolen secret, something the cosmos has reluctantly allowed us to overhear. And in this overhearing, we are caught in a strange tension. Are these bursts the dying gasps of collapsing stars, the aftershocks of cosmic violence, or the deliberate fingerprints of intelligence? Each answer carries its own weight. If they are natural, they remind us of the endless creativity of the universe, of how much remains hidden from our sight. If they are artificial, they would mark the first true contact with another mind, the shattering of our long-held solitude. Either way, the universe is no longer quiet. Scientists often describe FRBs as both a problem and a promise. A problem because their origins remain elusive, defying easy categorization. A promise because every new burst adds another piece to the puzzle, another opportunity to learn not only about the event itself, but about the universe it traversed. In chasing FRBs, astronomers are not just chasing explosions, they are chasing context, connection, and perhaps even confirmation that we are not alone. Picture for a moment the invisible rain of these bursts falling across the cosmos in every direction, each one a spark of energy that may or may not ever reach us. Somewhere right now, as you listen, one could be passing over the Earth too faint for our instruments to detect its story slipping by unnoticed. Somewhere else, a telescope might be catching one in real time, a tiny spike in data that will ripple through scientific journals and news headlines. Each burst is both fleeting and eternal, short in its moment, but lasting in its implications. To truly grasp them, to unlock their meaning, we must step back and remind ourselves what a signal is, how it differs from noise, and what it means to interpret a message written not in words but in physics itself. Because in the end, an FRB is more than a flash, it is a form of communication, whether from star or intelligence, or something stranger still. To move closer to understanding, we must return to the very foundation of what it means to hear anything at all, and ask again the ancient question, how do we know when the universe is speaking? From the very beginning of our attempts to listen to the universe, we have been haunted by one of the oldest problems in human history: how to tell the difference between a true message and meaningless noise. Our ancestors faced this challenge when they looked at the night sky and tried to decide whether a comet was a sign from the gods or just a wandering ball of ice. We face the same dilemma today, though, with far more sophisticated instruments, and far more tantalizing stakes. When a signal arrives, a sudden burst, or a strange pulse buried in the static, how can we be sure it is real, intentional, and extraordinary, rather than just a trick of nature or a glitch in our machines? The most famous example of this puzzle came on a summer night in 1977 at the Big Ear Radio Telescope in Ohio. The observatory was quietly scanning the sky as part of the SETI project, a program devoted to the search for extraterrestrial intelligence. For the most part, the data was dull, endless rows of numbers representing nothing more than background static. But then, on the 15th of August, one of the telescope's computers registered something unusual: a strong narrowband radio signal lasting 72 seconds. It was exactly the kind of signal scientists had imagined might come from an intelligent civilization because it occupied a very small slice of the radio spectrum, something nature rarely does by accident. The astronomer on duty, Jerry Eman, circled the string of numbers on the computer printout and wrote a single word in the margin: "Wow." The name stuck, and so did the mystery. For more than 4 decades, the WOW signal has stood as both a beacon of possibility and a lesson in frustration. It was strong, it was clear it came from space rather than from any human satellite, and yet it never repeated. Despite countless attempts to re-observe the same patch of sky, nothing like it has ever been heard again. The WOW signal sits right at the edge of belief, balanced between signal and noise. On one hand, it fits the expectations of what a genuine extraterrestrial transmission might look like. On the other, it failed the crucial test of science reproducibility. Without repetition, without confirmation, it remains a ghost, a single knock on the door of human awareness that was never followed by another. Was it a true message, a hello from someone unimaginably far away? Or was it just a natural burst of radiation that happened by chance to mimic the qualities of a deliberate transmission? This question reaches deeper than astronomy. It touches on the way human beings interpret meaning at all. The brain itself is a pattern-finding machine. From clouds that look like animals to coincidences that feel like fate, we are wired to see signals in noise. It is what allowed our ancestors to survive hearing a rustle in the grass and assuming it was a predator rather than dismissing it as the wind. But this same talent makes us vulnerable to illusion. When we scan the cosmos, we may be too eager to see intention to interpret every anomaly as a sign. The WOW signal is both thrilling and dangerous for this reason. It asks us to walk a tightrope between hope and skepticism. In the decades since, technology has improved dramatically. We now have arrays of radio telescopes that can monitor large swaths of the sky simultaneously, instruments sensitive enough to detect signals weaker than a whisper across intergalactic distances. And yet the basic challenge remains the same. How do we separate a true message from the endless chatter of the cosmos? Pulsars once tricked us. Their regular beats, so precise, they were nicknamed LGM for Little Green Men. Microwave ovens at observatories have been mistaken for mysterious bursts. Satellites, radar, and even car engines can contaminate the data. The line between discovery and error is razor thin. Part of the answer lies in looking for repetition, because a repeating signal is far less likely to be random. Another part lies in identifying structure, mathematical patterns that stand out against the natural background. But even then, interpretation is fraught. Nature is more inventive than we imagine, and often it produces structures that mimic design. The universe has a way of keeping its secrets close, daring us to misinterpret. Imagine for a moment sitting in a darkened room filled with static. You lean in, straining your ears, and then you hear a voice, or what sounds like one calling your name. But when you listen again, it is gone. Was it real, or did your mind conjure it out of the noise? That is the experience of astronomers when confronted with signals like the WOW event. The heart leaps at the possibility of contact, only to be dampened by the cold discipline of science which demands confirmation. Hope and rigor wrestle within the same moment. The WOW signal endures in popular imagination precisely because it was never explained. If it had been traced to a passing satellite or a quirk of equipment, it would have faded into obscurity. But because it sits unresolved, it has become a symbol of both our longing and our uncertainty. It reminds us how vast the sky is, how thin our net of observation, and how fragile each clue can be. And so the great question remains, what if it really was a knock on the door? If someone out there was trying to get our attention, how would we recognize it? What counts as a signal across the abyss of space? Do we look for mathematics, for prime numbers and ordered sequences, the language we assume is universal? Or might they speak in ways we cannot yet decode, using physics or dimensions beyond our comprehension? Every time we tune our cosmic ears, we are asking these questions. We are listening not just for sound, but for intention, for meaning, for something that says we are not alone. But intention is the hardest thing to prove, especially when all we have is data etched on a computer screen, a burst of numbers that may be a message or may be nothing at all. This is the razor's edge on which the search for extraterrestrial intelligence balances. It is an act of faith and doubt woven together, a willingness to be fooled in the hope of one day being right. The wow. Signal may never return, but its echo continues to guide us. It whispers that the difference between signal and noise is not always obvious, and that somewhere in the static of the universe there may still be another voice waiting to be heard. If that voice exists, if someone really is reaching out, the next question becomes unavoidable. How will they choose to speak to us? What kind of language bridges the gulf between stars, between minds, between species who have never met? If the universe is filled with whispers, then perhaps the real mystery is not whether they are there, but whether we will recognize the words when they finally arrive. Imagine for a moment that you are floating in the silence of interstellar space, your ship adrift between stars, and suddenly a signal arrives. It is not a voice, not music, not any sound you have ever heard. Instead, it is a rhythm, a sequence of pulses arranged in a way that feels deliberate. You begin to count them. 2, 3, 5, 7, 11. Prime numbers. A pattern that cannot emerge from chance alone. A sequence that speaks across the gulf of light years without needing words. In that moment, you would know beyond doubt that intelligence exists elsewhere. And more than that, you would know that mathematics is the bridge. For decades, scientists have assumed that if another civilization wanted to make contact, they would use mathematics as the foundation of their message. Unlike spoken or written language, which is bound to culture and biology, mathematics seems to stand outside of individual worlds. A triangle has 3 sides, whether you are human, alien, or machine. The ratio of a circle's circumference to its diameter is pi, whether measured on Earth in a galaxy far away or in a universe governed by the same laws of geometry. In this sense, mathematics feels less like a human invention and more like a discovery, a structure woven into the very fabric of reality. This idea is what gives rise to the expectation of signals built from prime numbers, the golden ratio, or simple geometric sequences. They are thought of as universal signposts, intellectual lighthouses that any advanced being would recognize. Carl Sagan, in his famous novel Contact, imagined a message encoded through mathematics, where numbers acted as the shared alphabet between species who otherwise could never converse. The logic is seductive. If the universe has one language, surely it is mathematics. But as with everything in the search for extraterrestrial intelligence, this assumption comes with its own paradoxes. On one hand, math feels like the most objective language we have. On the other hand, what if our experience of it is shaped entirely by our human way of perceiving? We see patterns, we label them, and we assign meaning to relationships between numbers. But does the universe truly speak mathematics? Or do we impose that order on chaos because our minds are tuned to see structure? A spiral galaxy appears beautiful to us, partly because it echoes the Fibonacci sequence, the golden ratio we find pleasing in shells and flowers. But to another species with a different biology, different senses, and different ways of cognition, would that same ratio mean anything at all? This question has been debated by mathematicians and philosophers for centuries. Plato believed that mathematical forms were eternal truths, existing independently of the human mind. Numbers were not inventions, but discoveries, glimpses into a deeper order that transcended space and time. In contrast, thinkers like Leopold Kronecker argued that numbers themselves are creations of the human brain, tools we made to measure and describe the world, but not realities in themselves. If Plato was right, then mathematics is truly universal, and any intelligent being must eventually stumble upon the same truths we do. If Kronecker was right, then math might be as parochial as language, a mirror of our own way of thinking, rather than a key to cosmic understanding. The implications for communication are enormous. If we send out prime numbers into the void, confident that they scream intelligence to anyone listening, what if they are as meaningless to another species as birdsong is to us? What if they do not conceptualize quantity the way we do? Or what if their sense of order is not numerical, but rooted in something we cannot even imagine? Chemical gradients, multidimensional harmonics, or patterns of gravitational waves. We assume math is the obvious choice because it is the closest thing we know to objectivity. Yet objectivity itself may be a human illusion. Still, the elegance of mathematics cannot be denied. Consider the beauty of the hydrogen line, the frequency emitted when hydrogen atoms flip their electron spins. Hydrogen is the most common element in the universe. Any being that looks up at the stars must know it well. A transmission sent at that frequency or encoded around it has long been thought of as a likely beacon for interstellar messages. It combines physics and mathematics into one. It says here is a signal anchored in the most basic building block of matter, a message in the language of atoms themselves. And yet even here the paradox returns. Hydrogen sings this song whether or not anyone listens. If an alien intelligence deliberately used that line, would we recognize it as an intentional signal or dismiss it as just another natural emission? Once again, the boundary between signal and noise blurs, and our reliance on mathematics becomes both our greatest tool and our greatest blind spot. Hearing mathematics in the cosmos is a bit like listening to music in the wind. Sometimes the patterns are real, born of structure and design. Sometimes they are illusions created by our longing for order. The question is whether we are attuned enough to tell the difference, and whether our version of order is truly shared by others. There is something profoundly human about turning to numbers when words fail us. We send radio pulses carved into sequences of primes because we believe that any mind capable of building a radio telescope must also be capable of counting. We inscribe golden ratios into spacecraft plaques because we imagine beauty is not subjective but absolute. We whisper equations into the darkness because we hope that somewhere someone else will recognize them as familiar. It is an act of faith disguised as logic, a hope that our truths are not just ours, but everyone's. Still, one cannot help but wonder, what if our faith in mathematics blinds us to other possibilities? What if the real key to interstellar communication is not numbers, but something stranger, something we have not yet dared to imagine? Perhaps mathematics will be our Rosetta Stone, or perhaps it is only one dialect among many. The cosmos may hold countless ways of speaking, and we may be prepared for only one, and so the paradox deepens. If mathematics is universal, then we are right to search for signals written in its patterns. If it is not, then we may be waiting for a reply that will never come deaf to the true voices around us. To solve this mystery, we must stretch beyond our own assumptions, beyond the comfortable certainty of numbers. Because if not mathematics, then what language might an alien intelligence choose? And would we even recognize it if it reached us? Imagine a night sky that is not silent, but filled with steady heartbeats echoing across the abyss. In the late 1962, when radio telescopes first began to peel back the static veil of the heavens, astronomers stumbled upon something that made their blood run cold. There, hidden in the noise, was a perfectly regular pulse, ticking with astonishing precision every second like the rhythm of a cosmic metronome. Unlike the erratic flashes of quasars or the drifting signals of stars, This was disciplined, unwavering, impossibly consistent. To the scientists who first encountered it, there was only one conclusion that seemed to fit: this must be a signal from another intelligence. After all, what in nature could beat with such mechanical regularity? For a brief and electrifying moment, humanity thought it had found proof of extraterrestrial life. The first pulsar was even nicknamed LGM, one short for Little Green Men. The name was half in jest, half in awe, a reflection of how unprepared the scientific world was for such an anomaly. The discovery had come through the meticulous work of Jocelyn Bell, a graduate student at Cambridge, who spent countless hours poring over long rolls of chart paper from a radio telescope. In those patterns of ink, she noticed a signal that returned every 1.33 seconds too sharp and too ordered to be dismissed as mere interference. Her advisor, Anthony Hewish, initially doubted, thinking it might be human-made radio contamination. But the signal persisted, moving with the stars, never tied to Earth. It had to be celestial. When more pulsars were found, each with its own perfect rhythm, the alien hypothesis began to crumble. This was not the work of one distant civilization sending greetings across the void. This was something deeper, stranger, more profoundly natural. Eventually, the mystery unraveled. Pulsars were revealed to be neutron stars, the collapsed remains of massive stars that had gone supernova. What had once been a roaring, luminous sun became a sphere only a few miles across, packed so densely that a teaspoon of its matter weighed billions of tons. These stars spun rapidly, some rotating hundreds of times per second, and as they rotated, they emitted beams of radio waves from their magnetic poles. Like cosmic lighthouses, these beams swept across space, and if Earth happened to be in the path, we received a pulse every time the beam rotated our way. What had seemed like the disciplined call of another intelligence turned out to be the echo of stellar death. The universe itself was the architect, crafting signals so precise that they fooled some of the most brilliant minds of their generation. But rather than disappointment, this realization sparked awe. Nature, it seemed, was capable of speaking in voices that sounded artificial, producing rhythms and patterns so uncanny they could pass for intentional design. This lesson carried a deeper warning. If pulsars could mimic the clarity of an intelligent signal, how many other cosmic phenomena might mislead us? How often might we mistake the voices of stars for the whispers of civilizations? The boundary between signal and noise between mislead us. Message and phenomenon is not always easy to draw. Pulsars remind us that the universe is more creative than we give it credit for, weaving order from chaos in ways that can baffle even the sharpest human eyes. And yet the story of pulsars also reveals something beautiful about our search for meaning. Even when the explanation was found, the romance of that first moment, when a group of young astronomers wondered if they were listening to alien beacons, remains etched in history. It captures the thrill of discovery, the fragile line between science and imagination. The fact that the answer was natural rather than extraterrestrial does not diminish the wonder. If anything, it enlarges it. For who could have predicted that the collapsed corpses of stars would sweep their beams like cosmic lighthouses, ticking like celestial clocks, broadcasting their existence across millions of light years? Pulsars, in their own way, became more than curiosities. They turned into tools. Their precision allows astronomers to measure time with incredible accuracy, rivaling even atomic clocks on Earth. Some pulsars spin so fast and steadily that they are used to test the fabric of space-time itself, to probe the presence of gravitational waves, to map the galaxy in ways once thought impossible. What began as a potential alien message evolved into one of the most profound natural discoveries of the 20th century. There is something humbling in this transformation. The very signals that once sparked speculation about other minds in the cosmos ended up teaching us more about the universe than we ever expected. In that sense, the pulsars did speak to us. They told us a story of collapse and endurance of stars that die but refuse to vanish quietly, choosing instead to announce their remnants in steady cosmic rhythm. Their message was not crafted by intent, but it was a message nonetheless, a reminder that nature itself can astonish us, and that the line between life and death, signal and silence, can blur in ways we never imagined. Perhaps this is why pulsars occupy such a special place in the human imagination. They are at once ghostly and mechanical, alive with rhythm yet born of destruction. To listen to a pulsar is to hear the universe counting steady and indifferent, but also strangely intimate, as though some great cosmic clockmaker left behind instruments to remind us of the passage of time. They make us question our assumptions, not just about what intelligence might look like, but about what nature itself is capable of producing. And so the discovery of pulsars lingers as a parable. The first time we thought we had found aliens, it turned out we had only found nature doing something we did not yet understand. That does not lessen the search. If anything, it sharpens it. For if pulsars taught us anything, it is that the cosmos has 1,000 voices, and some of them will sound stranger than we can predict. The danger is not that we will never hear another civilization, but that when we do, we may not recognize it, mistaking it for another trick of the stars. But not everything can be explained away so neatly. Not every signal folds back into a natural explanation. Some bursts, some anomalies, some patterns still resist our best attempts at understanding. And that perhaps is the most tantalizing part. For while pulsars revealed the power of nature to mimic design, they also left us wondering, what if one day the rhythm really is intentional? What if one day the voice in the static is not a shadow of a dying star, but the breath of another? Intelligence across the void. When scientists first encountered the sudden violent blasts of energy we now call fast radio bursts, most explanations leaned toward the natural. Collapsing stars, colliding neutron stars, the magnetic tantrums of magnetars, or even the birth cries of black holes. These were dramatic possibilities, yet all grounded within the laws of physics as we understood them. But not everyone was content to stop there. For some, the very strangeness of FRBs invited a bolder thought, one that whispered of something beyond familiar astrophysics. What if these bursts were not accidents of nature at all? What if they were crafted? The idea sounds like science fiction, but it rests on an uncomfortable truth. FRBs are powerful enough and precise enough that they could in principle serve as tools of technology. Some researchers proposed that what we were hearing might be the exhaust of a machine so vast, so advanced, that it operated on scales dwarfing our entire planet. In 2017, a team of Harvard astronomers floated the daring suggestion that FRBs might be evidence of extraterrestrial engineering. Specifically, they considered the possibility that the bursts could be tied to something called sail propulsion. On Earth, engineers have toyed with the dream of light sails, enormous sheets of reflective material pushed by photons. The concept is simple, in principle, almost poetic. Sunlight itself can act like wind pushing a craft across the emptiness of space. Tiny prototypes have even been tested in orbit. But the dream of interstellar travel demands something more powerful than the faint whisper of starlight. Enter the idea of beamed propulsion. Instead of waiting for natural light to do the work, you create a concentrated beam, laser, or radio that hammers into the sail, driving it forward at astonishing speeds. In this vision, a civilization with enough energy could build engines of pure light lighthouses that are not only for seeing, but for moving. Now imagine scaling that up far beyond our capacity. A civilization harnessing the power of an entire star could create radio beams vast enough to push ships the size of cities across interstellar space. Such beams would be visible from galaxies away, lighting up our radio telescopes with bursts of energy unlike anything else. From our perspective, it would look exactly like what we now see, sudden concentrated explosions of radio power coming from nowhere, disappearing just as quickly. In other words, FRBs could be the cosmic equivalent of watching the headlights of traffic far down a highway you cannot yet see. It is a startling possibility, one that turns the universe into a vast ocean, not only filled with drifting stars, but with currents of technology, ships, and intentional design. If even one FRB were proven to be artificial, it would change everything. It would mean that we are not only not alone, but that someone out there has already mastered interstellar travel on a scale we can barely dream of. It would mean that the great silence we fear may simply be an illusion, a blindness on our part because we have mistaken the roars of passing engines for the growls of dead stars. And yet, as intoxicating as this vision is, it also carries its own sobering weight. The energies involved in FRBs are almost unimaginable. To create them artificially would require a mastery of physics that puts such a civilization not just decades but perhaps millennia ahead of us. They would wield technology that from our vantage point looks indistinguishable from magic. Could we even comprehend the intentions of such beings, much less hope to interpret their signals? Would the bursts we receive be a byproduct like exhaust fumes drifting in the wind rather than a deliberate message? The speculation is tempting, but science demands caution. Extraordinary claims require extraordinary evidence. To leap too quickly to the alien hypothesis risks blinding us to natural explanations waiting just around the corner. After all, pulsars once seemed like alien beacons too, until we learned that they were the remnants of dead stars spinning in silence. Perhaps FRBs will one day reveal a natural mechanism, just as surprising one, that makes our current guesses look quaint. But still, the possibility lingers, and with it the haunting thought, maybe the line between cosmic phenomena and cosmic engineering is thinner than we think. There is also another layer to consider. If FRBs are natural, they expand our knowledge of physics in thrilling ways. But if even one is artificial, then the implications ripple far beyond astronomy. It would mean that interstellar travel is not only possible, but already happening. It would mean that civilizations can survive long enough to wield star-level energies, that intelligence does not always end in self-destruction, that the universe might be filled not only with stars but with traffic. For a species like ours, still tethered to its single fragile world, still dreaming of Mars, the mere possibility is enough to alter our imagination. Some scientists reject the alien hypothesis, outright seeing it as a distraction from more rigorous inquiry. Others keep the door slightly ajar, not because they are convinced, but because history has taught them humility. The universe is older, larger, and stranger than we expect, and our catalogue of cosmic phenomena is still in its infancy. The day may come when one signal resists every natural explanation, when no known physics can account for it, when the only remaining option is that we are witnessing intent. Until then, speculation about alien engines remains a mirror, reflecting both our hopes and our fears, both our longing to connect and our dread of what connection might mean. For now, the bursts remain enigmas, flickers of radio fire that tease us with possibilities. They are either the voices of exotic astrophysics or the footsteps of civilizations we have never met. Either way, they remind us of how much we do not yet know and how much wonder still waits in the sky. And before we allow our imaginations to drift too far, before we leap from speculation into certainty, we must pause and return to the foundation. To even begin to understand what FRBs are, we must first ground ourselves in the very fabric they are made of. What are radio waves really? What is this invisible medium that carries both the chatter of humanity and the whispers of the cosmos? Only by understanding the nature of the waves themselves can we hope to tell the difference between accident and intention, between the silence of dead stars and the voices of living minds. When most of us think about the universe, we imagine the night sky the way our eyes reveal it to us. Stars glitter like pinpricks on black velvet. The moon glows with its gentle silver light. And if we are far from city lamps, we can even make out the soft band of the Milky Way stretching from horizon to horizon. To us, this view feels complete, as if we are seeing the universe for what it truly is. Yet in reality, what our eyes capture is only the tiniest sliver of a much larger and more complex reality. Visible light is nothing more than one narrow window carved out of an enormous invisible spectrum, the tip of a cosmic iceberg floating in the dark sea of space. Radio waves, gamma rays, X-rays, microwaves, infrared, all of these are also forms of light, even if they do not register in our retinas. They are all part of the electromagnetic spectrum, an elegant continuum of waves that differ not in kind, but only in frequency and wavelength. From the shortest energetic gamma rays to the longest lazy radio waves, the spectrum spans across an unimaginable scale, stretching from the fraction of a femtometer to kilometers in length. Our eyes, miraculous as they are tuned to only a minuscule range of this expanse. It is as though nature gave us a keyhole and told us to mistake it for a window. The truth is that if we could see radio waves, our night sky would appear utterly transformed. Stars might no longer dominate the view. Instead, we would see strange halos and filaments, the quiet hum of hydrogen clouds glowing with faint emissions, the hiss of remnants from exploding stars, the restless sparks of pulsars, and the faint radio whisper of galaxies so distant their light has traveled for billions of years. It would be as if a curtain were lifted and a second hidden world suddenly revealed itself, one that has always been there just beyond the reach of our fragile human senses. The revolution came when we learned how to build machines to extend our sight. The invention of radio astronomy in the 20th century was not just about tuning into a new wavelength. It was about stepping into an entirely parallel universe, a place that exists in the same coordinates as the visible cosmos, yet looks profoundly different. A familiar galaxy seen in optical light might look like a serene whirlpool of stars, but in radio it could blaze with the fury of its central black hole, spewing jets of energy, thousands of light years long. A patch of dark sky in visible light, apparently empty, might reveal itself in radio as a crowded field of strange, bright objects, each one a beacon from across the void. This shift of perspective is almost philosophical. It forces us to realize that the universe is not what it appears to be. What we see with our naked eyes is only a convenient illusion, a shallow mask over a deeper and richer reality. Every frequency reveals new phenomena, each invisible to the others. Infrared unveils the heat of star-forming nurseries. Ultraviolet shows us the raw violence of young suns. X-rays highlight the bones of galaxies where black holes feed and supernovae blast apart. And radio is where we hear the echoes of cosmic engines and the faintest signals carried across the emptiness. To embrace the invisible spectrum is to accept that we live inside a layered cosmos, one that can never be fully known from a single perspective. Astronomers sometimes compare this to a blind person running their hands across a sculpture. Each pass reveals something new, a curve, a ridge, a hollow, but never the whole shape at once. The spectrum is our way of piecing together the contours of the universe frequency by frequency, each band filling in details that the others cannot. And among all these hidden layers, radio is uniquely haunting. Because of its long wavelengths, it can travel immense distances, bending around obstacles, slipping through dust clouds that block visible light. That makes it a privileged messenger able to carry whispers across billions of years of cosmic history. When we listen in radio, we are not just seeing, we are overhearing. The universe in its natural processes broadcasts constantly. It is like walking into a crowded hall where everyone is speaking at once. Some voices near others faint, some whispering in languages we do not yet understand. This is why the discovery of FRBs and other strange phenomena resonates so deeply. In the radio spectrum, the cosmos feels alive in a way it does not in visible light. It chatters, it hums, it bursts with sudden energy. It reveals processes invisible to every other sense we possess. To an optical telescope, a galaxy may appear calm, its starlight steady. To a radio telescope, that same galaxy may be ablaze with jets, eruptions, and unseen engines of power. The shift is not only scientific but emotional. It is like discovering that the quiet neighbor you thought you knew has a secret life as a thunderous musician. The invisible spectrum invites humility. It reminds us that reality is always bigger than what our senses suggest. Imagine if we had never discovered radio astronomy at all, if we had lived our entire scientific life believing the optical sky was the whole truth. We would have missed pulsars, quasars, cosmic background radiation, and the very signals that led us to the Big Bang itself. In many ways, the invisible spectrum is the true canvas of the universe, and visible light is merely one color splashed across it. To gaze into the radio sky is to experience the familiar transformed. It is like stepping into a parallel dimension where the constellations no longer align, where new patterns emerge, where silence becomes filled with music. We are still learning to interpret this song, still straining to separate harmony from noise, but the very act of listening has already reshaped our understanding of existence. And it is within this invisible realm, this hidden world layered atop the one we think we know, that some of the universe's most startling surprises have revealed themselves. Surprises that challenge our ideas of nature, technology, and intelligence. Surprises that force us to ask whether what we are hearing is merely the background murmur of a restless cosmos, or whether just maybe it is something else entirely. Every time we point a radio telescope toward the sky, we are not just opening our ears to the present, we are eavesdropping on history. Every signal that reaches us has traveled an immense distance, and with that distance comes time. A burst of radio energy arriving tonight may have left its source millions of years ago, perhaps even before the first mammals walked the earth. In that sense, the universe is not just a place, but a memory, and each signal is a kind of time capsule, a letter written long ago and only now delivered to our doorstep. This idea is both beautiful and unsettling. If we imagine the cosmos as a vast ocean, then every wave lapping against our instruments carries with it a trace of something long vanished. The FRBs and other radio signals we detect today are not whispers from the present, but echoes from the deep past. A civilization powerful enough to beam messages across interstellar space might have flourished millions of years ago, but the signals we hear from them would still be only now arriving, carried faithfully across the gulf of time. By the time we receive their message, the senders themselves may have disappeared. Their cities dust, their suns dimmed, their entire species reduced to a memory carried on a wave of light. This is the paradox of cosmic communication. On Earth, dialogue depends on immediacy. We speak, we hear, we respond. Even when separated by continents, a signal bounces from satellite to receiver in fractions of a second. But across the vastness of interstellar distances, even the speed of light is too slow. A message sent from a star 1,000 light-years away would take 1,000 years to arrive, and our reply would take another 1,000 years to return. That means the conversation could never truly be a dialogue, only a chain of monologues separated by centuries. By the time our answer arrived, the original questioner might no longer exist, or their society might have changed beyond recognition. The time capsule nature of signals also means that many of the mysteries we wrestle with may already be obsolete. When we puzzle over whether a strange burst is artificial, when we wonder if it could be the product of technology, we are effectively asking a question about a past that is no longer accessible. If it were technology, then the beings who built it may no longer be alive to confirm it. We may be listening not to neighbors, but to ghosts, to the final traces of civilizations that rose and fell long before humanity ever dreamed of space. In that light, every detection becomes haunting. We are not just scientists analyzing data, we are archaeologists brushing dust from relics whose makers can never be questioned. And yet the melancholy of this truth does not erase its wonder. Imagine finding a fragment of pottery buried deep in the desert, a shard that tells you people once lived here, once loved, once built and dreamed. You cannot speak to them, but the shard is proof of their reality. In the same way, a signal, even if never repeated, is evidence that something once existed out there, something powerful enough to be heard across light years. To know that we are not the first to reach for the stars, even if those before us are long gone, is still to be comforted by the thought that intelligence has bloomed more than once in the garden of the universe. This awareness casts our own existence in a different light. We too are sending signals into space, though often unintentionally. For more than a century, Earth has been leaking radio waves into the cosmos, carrying fragments of our culture outward at the speed of light. Television broadcasts, radar pings, satellite transmissions, all of these are forming a growing sphere of human noise, expanding through the galaxy. A distant civilization tuning in millions of years from now might hear our own voices long after we are gone. To them, we will also be ghosts. Our sitcoms and news reports, our desperate transmissions and trivial chatter could become the time capsules that define humanity in some distant mind. It is strange to think that this inevitability may mean all interstellar conversation is doomed to be one-sided. Perhaps the universe is full of civilizations, but each one is separated not just by distance, but by time. Civilizations may rise and fall like sparks in the dark, rarely overlapping each, leaving behind nothing more than faint echoes. In such a scenario, the cosmos may not be silent, but asynchronous. It speaks, but not in conversation, rather in soliloquies drifting forever into the void. This realization can be sobering, even discouraging. If dialogue is impossible, if every attempt at contact is fated to be nothing more than archaeology, then what is the point of listening? Why strain our machines? Why build ever larger telescopes? Why devote years to parsing the faint hiss of static if the conversation has ended before it began? But here lies a subtle truth. Meaning is not always found in the reply. Sometimes to hear a voice at all, no matter how faint or how far away, is enough. To know we are not alone in the great experiment of existence may be more valuable than any exchange of words. Even the ghost of a signal carries weight. It tells us that intelligence is not impossible, that life can rise to self-awareness, that the laws of physics do not forbid thought from blooming among the stars. It suggests that the story of the cosmos is not only about stars and galaxies, but also about minds, however brief their flicker may be. Each time capsule signal is like a candle held up in the dark, reminding us that somewhere, sometime, others have walked this path. And so the act of listening becomes less about conversation and more about communion with history. Every time we catch a burst, we are bearing witness to a story written long before us. We are joining a chain of observers across time, each one catching the traces left behind by those who came before. Perhaps that is the role of intelligence in the cosmos. Not to chatter endlessly across the stars, but to recognize, honor, and remember. Yet the paradox remains. If communication is doomed to be ghostly, why do we continue? Because to stop listening would be to close our ears to the possibility that one day, against all odds, we might catch a signal from not just the past but the present. Perhaps civilizations do overlap, perhaps one survives long enough to bridge the gulf. Even if the odds are vanishingly small, the possibility is enough to drive us forward. For in the vast, indifferent universe, even the chance of dialogue is too precious to ignore. In the end, each signal we hear, whether natural or artificial, recent or ancient, is a reminder that the cosmos is alive with memory. It is a vast archive of voices waiting for those who dare to listen. And though most of those voices may be silent now, their echoes reach us, still fragile and fleeting, carried across time to remind us that we too are temporary, and that the story of the universe is far older, richer and stranger than we can ever imagine. For more than half a century, humanity has been leaning into the silence of the universe, cupping its ear to the cosmos as if hoping to catch a whisper in the wind. This effort has a name, one that has become almost mythical in the world of science and imagination alike. SETI, the search for extraterrestrial intelligence. It is not a single experiment, but a long tapestry of attempts woven together by generations of scientists who, despite disappointment after disappointment, refuse to stop listening. The image is almost poetic. Giant radio dishes, aimed at the heavens, scanning across star fields, night after night, hunting for a signal that breaks from the background hiss. Each telescope is like a colossal ear pressed against the cosmic wall, straining to hear what might be faint, deliberate, and extraordinary. The premise of SETI is at once simple and profound. If intelligence has arisen elsewhere, if another species has built tools and pondered the stars, then surely some of them may have tried to send out messages. Radio waves, after all, are efficient travelers capable of crossing interstellar distances with little distortion. They can carry patterns, codes, perhaps even greetings. But the problem is not sending or receiving. It is recognizing. Natural phenomena flood the universe with noise. Pulsars, quasars, magnetars, and the cosmic microwave background all hum, in frequencies that overlap with what an artificial signal might look like. The challenge is to separate the intentional from the accidental, the deliberate transmission from the static of creation. To accomplish this, SETI searches for order within chaos. One famous strategy has been to look for narrowband signals, transmissions confined to an extremely tight frequency range. Such signals almost never occur in nature. A narrow band spike sharp as a needle against the noise would be a compelling clue that someone somewhere was trying to be heard. Another approach has been to look for repeating sequences, the cosmic equivalent of a drum beat that cannot be mistaken for random thunder. Even a short artificial pattern could be enough to prove that we are not alone. Yet in decades of scanning, the heavens have remained stubbornly ambiguous. Strange bursts appear, but none repeat, none confirm, none settle the debate. The most famous of these was the so-called WOW signal in 1977, a 72-second burst that looked tantalizingly like the kind of narrowband transmission SETI dreams about. The astronomer who saw it was so startled he scrawled "WOW" in the margins of the data printout, giving the signal its legendary name. For a brief moment it seemed the silence had been broken, that at last the cosmos had spoken back, and then nothing. The signal was never heard again. No repetition, no follow-up, no explanation. To this day, it remains one of the great enigmas of SETI, a single note from an unknown instrument played once and never again. This is the rhythm of the search, long stretches of emptiness, punctuated by fleeting hints that evaporate under scrutiny. Some would call this futility, but for the people of SETI it is precisely the opposite. The silence is a canvas on which the imagination paints possibilities. Every night of listening is an act of faith, a refusal to accept loneliness as inevitable. To dedicate your life to SETI is to embrace uncertainty, to accept that the answer may not come in your lifetime or even in the lifetime of your civilization, but to search anyway, because the question itself is too important to abandon. In that sense, SETI is less about aliens than about us. It reveals something raw and undeniable about human beings. We do not want to be alone. From campfires to cathedrals, from myths to mathematics, we have always yearned for connection beyond ourselves. SETI is the scientific embodiment of that yearning, a way of turning longing into method, curiosity into instrumentation. Whether or not the cosmos is crowded, the act of listening affirms that we believe it could be. It is our way of saying to the universe, "We are here, and we are ready to know if you are too." Of course, the search has not been without controversy. Critics point to the decades of empty data and ask whether the resources could be better spent on problems closer to home. They argue that the chances of stumbling across an intentional transmission are vanishingly small, that civilizations might prefer other forms of communication, or that they might be rare to begin with. Some go further, warning that active attempts to broadcast could be dangerous, that announcing our presence might attract not friends but predators. And yet, even with these warnings, the hunt goes on. The allure of the unknown outweighs the fear, and the possibility of discovery, however, slim, keeps telescopes turning skyward. Interestingly, SETI has yielded treasures even without the jackpot of a confirmed alien signal. In the process of scanning the heavens, scientists have discovered countless natural phenomena that might otherwise have remained hidden. Entire catalogues of pulsars were expanded, mysterious radio transients were logged, and the intricate behavior of interstellar gas and plasma was revealed in greater detail. The cosmic hunt for intelligence has doubled as a deeper exploration of the universe itself, reminding us that even false alarms can expand our understanding. To chase the extraordinary is to illuminate the ordinary in ways we did not expect. This dual nature, searching for others, discovering ourselves, has become one of SETI's quiet legacies. It is not only about the potential of extraterrestrial minds, but about the human spirit of inquiry. Every time a radio dish is raised to the sky, we enact a ritual of humility. We admit that we do not yet know if we are unique, that the story of life may extend far beyond Earth. In this way, SETI is less a scientific project than a cultural mirror. It reflects our willingness to hope, to endure silence, to listen for a voice that may never come. Still, the possibility of success hovers like a shadow. What if tomorrow, amid the static, we caught a signal that was unmistakably artificial? A sequence of prime numbers, a digital pulse encoded with structure, a message that repeats until we cannot doubt its origin. The consequences would be seismic reshaping philosophy, religion, politics, and science in an instant. The discovery would not only confirm that we are not alone, but also force us to reconsider what it means to be human, to be part of a cosmic community. In every scan of the heavens, SETI holds open the door to that future, however unlikely it may seem. In the end, the great cosmic hunt is as much about the journey as the prize. SETI teaches patience in an age of instant gratification. It teaches persistence in the face of silence. It teaches wonder, reminding us that the universe is vast enough to hold secrets we cannot yet fathom. Whether or not we ever hear the voice we seek, the act of listening makes us larger, stretching our imagination to match the scale of the cosmos. And sometimes in science, as in life, it is the act of asking the question that matters more than the certainty of the answer. To listen is to hope, and to hope is to remain human. Perhaps that is the truest legacy of SETI, not only the possibility of finding others, but the certainty that in searching for them we discover something essential about ourselves. And just beyond the horizon of that search lies a truth we cannot ignore. Sometimes the hunt reveals wonders we were not even looking for. The danger in listening for voices in the cosmos is not only that the universe may stay silent, but that when it does murmur, we might misunderstand what it is saying. Human beings are remarkably good at seeing patterns where none exist. It is the same tendency that makes us spot faces in clouds or hear words in the wind. When a strange blip shows up on the astronomer's screen, it is tempting, perhaps irresistible, to imagine that it carries meaning. But meaning is not guaranteed. Sometimes what looks like the whisper of an alien civilization turns out to be nothing more than the hum of our own machines. One of the most famous cautionary tales in this regard unfolded not so long ago at the Parkes Observatory in Australia. For years, astronomers there had been puzzled by mysterious bursts of radio energy. They were short, sharp, and dazzlingly bright, exactly the kind of thing that could, if one let imagination run, be linked to distant technology. These bursts were christened perytons, named after mythical creatures that combined the wings of a bird with the body of a stag. They seemed to appear out of nowhere, leaving no clear trace of origin. The excitement was palpable. Were these the long-sought fingerprints of something non-human? A cosmic lighthouse flashing across the void? The truth was almost comical. After painstaking investigation, the culprit was revealed: not aliens, not exotic astrophysics, but microwaves. Specifically, the kitchen microwave at the observatory itself. When staff members grew impatient and opened the door before the timer finished, a burst of radio interference leaked out, mimicking the characteristics of cosmic signals. For years, the universe had seemed to be whispering, but in reality, it was lunch being reheated. The grand mystery was undone by leftovers. This story is humorous in hindsight, but it carries a weighty lesson. In our eagerness to decode the unknown, we must first master the discipline of skepticism. Nature produces oddities that can look artificial, and our own technology generates artifacts that can look cosmic. Before jumping to conclusions about advanced civilizations, scientists must eliminate every earthly possibility. The irony is profound. To search for the most extraordinary discovery in history, one must become an expert at ruling out the ordinary. And this problem is not limited to one observatory or one microwave. History is full of false alarms that highlight how fragile the boundary between noise and signal truly is. When pulsars were first discovered in the late 1962, their regular radio pulses were so precise that the discoverers jokingly nicknamed the source LGM, one short for Little Green Men. The idea was half in jest, half in genuine uncertainty. After all, what in nature could tick with such perfect rhythm? Only later was it understood that these were the remnants of exploded stars, neutron stars spinning at incredible speeds, beaming radio waves like cosmic lighthouses. What had looked like a message was in fact a monument of astrophysics. The lesson runs deeper still. Misinterpretation is not only a technical hazard, but a psychological one. Our longing for connection, our fear of loneliness, our hunger for wonder, all conspire to nudge us toward extraordinary explanations. Every anomalous blip is a chance for hope, and hope can be blinding. Scientists must tread carefully, balancing curiosity with caution, excitement with rigor. Without this balance, even the most disciplined observer can become a victim of their own expectations. This balancing act is at the heart of what makes the search so difficult. Imagine spending years combing through data hour after hour with nothing but static for company. Then one evening a spike appears, the heart leaps, adrenaline surges. What if this is it, the discovery that changes everything? But the discipline of science demands patience. That spike must be checked, rechecked, compared against databases of known interference, tested against atmospheric phenomena, examined for reproducibility. Only when every mundane explanation has been exhausted does the extraordinary even enter the conversation. Most of the time, the excitement fizzles out. Yet the act of restraint, the refusal to leap ahead, is what protects the integrity of the search. It is tempting to feel disappointed by such outcomes, but in truth, they are part of the scientific adventure. Each false alarm sharpens our instruments, improves our methods, and humbles our expectations. The microwave at Parkes may have ended one mystery, but it also fortified the resolve of astronomers to guard against self-deception. It reminded everyone involved that the universe does not owe us clarity. It speaks in riddles. And if we wish to understand, we must learn to separate our own echoes from its true voice. Still, one cannot help but wonder, what if one day the signal refuses to be dismissed? What if it repeats, persists, and passes every test of earthly interference? What if no catalogue of pulsars or quasars can account for it? No microwave door can explain it away. That possibility lingers in the background of every false alarm like a shadow cast by the future. It is the reason astronomers endure the long silences and the frequent disappointments. Because the only way to catch that undeniable signal, the one that will not evaporate under scrutiny, is to sift carefully through all the ones that do. The irony is beautiful in its own way. The same caution that makes discovery slow is also what ensures its credibility. A signal confirmed without doubt would carry the weight of centuries of patience and skepticism. It would be the most vetted communication in human history, born not of a rush to believe, but of relentless attempts to disprove. In that sense, every microwave mishap and every pulsar misinterpretation is not a failure, but a rehearsal preparing us for the day when the universe truly does speak. And if that day comes, we will know how to listen, not with naivety, not with premature conclusions, but with the patience of a species that has learned again and again how easily it can fool itself. The microwave oven at Parkes may have taught us humility, but humility may be the very thing that allows us one day to recognize the real thing when it arrives. For now, the static continues, the dishes turn skyward, and we wait. Somewhere in the silence, perhaps there is a message we have not yet mistaken for ourselves. To listen for voices in the cosmos is to do more than science. It is to wade into philosophy, into the deepest waters of meaning and identity. Every time we point a radio dish at the sky and wait, we are not just testing equations or running simulations, we are asking a question that has haunted humanity since its earliest stories. Are we alone? And if we are not, what does that mean for who we are? This is where astronomy brushes against the boundaries of philosophy and even spirituality. The search for extraterrestrial intelligence at its core is not only about discovering new facts, but about understanding our place in the vastness. To contemplate other minds, other cultures, perhaps even other histories unfolding light years away forces us to turn the mirror inward. Why do we want to know? What are we hoping to find, or perhaps what are we afraid to find? One of the most haunting concepts born of this quest is what philosophers and scientists alike have called cosmic loneliness. It is the quiet recognition that in a universe of staggering scale, we may be utterly alone, the only island of consciousness afloat in an ocean of indifferent stars. To imagine this possibility is to feel the weight of solitude on a planetary scale. The silence of the sky becomes more than a scientific puzzle. It becomes an existential ache. And yet the alternative carries equal gravity. If the universe teems with life, if civilizations bloom and spread like galaxies of thought and technology, then our uniqueness dissolves. We are no longer the singular miracle, the chosen spark, but one flicker among countless others. This vision can feel liberating or terrifying depending on the angle of our gaze. To some, it is comforting to think we are part of a grand cosmic community, however distant. To others, it is disquieting to imagine that our triumphs, our tragedies, and even our philosophies are but local dialects in a universe fluent in 1,000 voices. These two poles, utter solitude or overwhelming company, define the paradox at the heart of the search. Both outcomes would transform our worldview, each in opposite directions. If we are alone, then our planet becomes the rarest sanctuary in existence. Every forest, every ocean, every human life takes on a cosmic significance, for here alone has the universe opened its eyes. In that scenario, our responsibility grows immense. To squander Earth, to destroy ourselves, would be to extinguish the only known flame of awareness. If we are not alone, the implications ripple outward. History would need rewriting, religions might be reshaped, and philosophy would confront a new horizon. What does it mean to be human if the human is no longer the defining boundary of intelligence? Would we still think of ourselves as central, or would humility become the new foundation of wisdom? Our art, our science, our myths, all would be cast against the backdrop of an inhabited cosmos. The Copernican revolution, which once displaced Earth from the center of creation, would seem modest by comparison. There is, too, the matter of scale. Suppose we are not alone, but the nearest intelligent neighbors are so far that we can never truly converse. This possibility sits uneasily between the poles of solitude and community. It means we are not unique yet practically isolated. We would know that minds exist elsewhere, yet never share a word, never exchange a story. The universe in that case becomes a library of unread books, shelves upon shelves of civilizations whose pages never touch. Even within philosophy, there are competing visions of what contact or its absence would mean. Existentialists might see in cosmic loneliness a call to embrace freedom to carve meaning in an indifferent void. Religious thinkers might interpret the discovery of other civilizations as either a confirmation of divine abundance or a challenge to cherished narratives of creation. Pragmatists might focus less on meaning and more on responsibility. What policies, what ethics, what technologies should we develop in light of the knowledge that we are either alone or not? There is also the subtle but profound question of how such knowledge would reshape our daily lives. Would the awareness of solitude inspire greater unity on Earth? A recognition that we must cherish one another because there is no one else? Or would it deepen divisions with groups retreating into isolationist pride, claiming even more, fiercely that humanity is chosen, set apart? Conversely, if we discovered neighbors among the stars, would nations rally together in excitement, seeing themselves as part of something larger, or would old rivalries simply expand into new theaters of comparison? Philosophy has long prepared us for these questions, though never with answers that satisfy all. Plato wondered about the forms of reality beyond what we see. Pascal reflected on the infinite spaces that terrify him. Nietzsche spoke of eternal recurrence, the possibility that existence repeats endlessly. Each of these meditations, in their own way, brushes against the same horizon that modern radio telescopes now face. What is out there, and what does its presence or absence say about us? Perhaps the most sobering thought is that no answer can leave us unchanged. Silence is not neutral, it whispers of solitude. Contact is not neutral, it proclaims plurality. Even ambiguity, the long waiting without resolution, shapes us. The very act of searching disciplines our imagination, forces us to wrestle with humility, patience, and the vastness of time. In this sense, the search for extraterrestrial intelligence is itself a form of philosophy conducted with antennas instead of syllogisms. It is an inquiry into being an experiment in humility and a confrontation with the unknown. Just as philosophers once gazed into the night sky and saw metaphors for order and chaos, astronomers today gaze through radio waves and see the possibility of company or loneliness etched into static. And here lies the quiet irony. No matter what answer the cosmos gives or withholds, it changes us. To be alone means to bear the weight of being singular, the universe's only known witness. To be accompanied means to shed that uniqueness and join a chorus. Either way, the human story bends. Our myths, our philosophies, our politics, our very sense of self, all must expand to meet the reality we uncover. So when we tune into the silence, straining for signals buried in the noise, we are not just hunting for data. We are listening for echoes of our own place in the grand story. The universe, in its vast indifference, becomes a stage where we ask the oldest question in the newest way. And whatever the answer, it will not simply inform us, it will transform us. In 1950, at a lunch table in Los Alamos, physicist Enrico Fermi looked up from his conversation about flying saucers and asked a deceptively simple question: where is everybody? That single remark crystallized what would later be known as the Fermi paradox, a puzzle that has haunted scientists, philosophers, and dreamers alike ever since. If the universe is as vast and as old as we know it to be, if stars and planets are so plentiful, and if the conditions for life are not particularly rare, then intelligent civilizations should be everywhere. Yet the skies remain silent. Our telescopes return no greetings. Our radio dishes detect only the hum of natural processes. So where are they? The paradox lies in the clash between probability and observation. Statistically speaking, it seems almost impossible that Earth would be the only place where life emerged and evolved into intelligence. Billions of stars in our galaxy alone are orbited by planets, many in the so-called habitable zone where liquid water could exist. Some of those worlds are billions of years older than Earth, meaning they would have had ample time for life to not only arise but also develop technologies far beyond our own. If even a fraction of those civilizations had mastered interstellar travel, or broadcasting, the galaxy should be buzzing with signals, perhaps even littered with ancient artifacts. But instead we see nothing, hear nothing, find nothing. This silence is not a gentle absence but a roaring contradiction. The night sky looks infinite and fertile, yet it behaves as if barren. The Fermi paradox captures that tension and forces us to confront unsettling possibilities. Maybe we have not been listening long enough, our technological adolescence spanning barely a century in a universe billions of years old. Perhaps civilizations rise and fall so quickly that the chances of overlap are vanishingly small. A cosmic version of ships passing in the night, their lights never meeting. Or maybe the silence is not a void, but a message. To imagine that silence itself carries meaning is to shift from astronomy to philosophy. If intelligent beings are out there and deliberately keeping quiet, what does that say about them and about us? Some theorists suggest the zoo hypothesis, the idea that advanced civilizations know about us but choose to remain hidden, watching, without interfering, as zookeepers might watch animals unaware of their observers. Others suggest something darker, that the silence is a kind of camouflage, a strategy for survival, in a universe where broadcasting your presence could invite predators. Then there is the sobering thought that perhaps there is no one left to speak. Civilizations may arise but burn out, consumed by their own technologies, undone by environmental collapse, or extinguished by cosmic catastrophes. If the lifespan of intelligent societies is short compared to the age of galaxies, then the odds of two existing at the same time close enough to communicate are vanishingly slim. In this view, the silence we hear is not neglect, but absence, a graveyard quiet. Of course, there is always the possibility that our assumptions about communication are too narrow. We expect radio signals because that is what we ourselves use. But perhaps advanced beings employ methods beyond our comprehension. Neutrino beams, gravitational wave encoding, or technologies so exotic we would not even recognize them as communication. To a civilization thousands or millions of years more advanced, our radio telescopes might look as quaint as smoke signals. In that case, the universe could be alive with chatter, but we simply do not know how to tune in. What makes the Fermi paradox so powerful is that it resists resolution. Every proposed answer raises further questions. If the galaxy is full of life, why have we not seen even the faintest trace? If it is empty, why does the math suggest otherwise? The silence stretches between these two poles, daring us to interpret it. Some scientists argue that the paradox is overstated, that our search has barely begun, and that a few more centuries of listening might well yield results. Others argue that the silence is telling us something profound about the nature of life and intelligence. Perhaps that we are in fact rare, maybe even unique. There is a certain humility in confronting this paradox. It reminds us that our perspective is small, our data incomplete, our imagination limited. It also reminds us of the stakes. If we are alone, then we are the universe's only known voice, and that makes our survival infinitely precious. If we are not alone, then the silence might be a warning, an indication that speaking too loudly in the cosmos carries risks we cannot yet fathom. Either way, the paradox does not leave us neutral. It pushes us to think about ourselves in cosmic terms, about what it means to exist in a universe that is so fertile on paper, yet so mute in reality. Fermi's question, tossed into a lunchtime conversation more than 70 years ago, continues to echo because it does not resolve. It sits at the intersection of astronomy, probability, and existential philosophy, asking us to reckon with our expectations and our fears. Perhaps the most haunting aspect is that silence does not close the case. It remains open-ended, a blank canvas on which we project our hopes, our anxieties, and our sense of significance. And so, beneath the quiet stars, we keep imagining. We imagine bustling galactic civilizations just beyond our reach. We imagine a lonely Earth as the sole island of thought. We imagine futures where we send our own signals into the void, hoping someone somewhere someday will hear. The Fermi paradox is less a riddle to be solved, and more a mirror, reflecting our own uncertainties about meaning, existence, and destiny. In the silence, our imagination takes root, filling the void with possibilities both wondrous and terrifying. And in that very act of imagining, in spinning stories to answer a question that the universe refuses to answer for us, we begin to see the paradox for what it truly is. Not just a scientific puzzle, but a meditation on who we are and what we dare to hope for. From the moment human beings first looked up at the night sky and wondered if someone might be looking back, our imaginations have been weaving stories around the possibility of messages from the stars. The cosmos is not only a scientific frontier, but also a canvas for dreams, anxieties, and narratives that stretch beyond what data can provide. A single idea, the notion of a signal, faint but intentional, crossing the gulf of space, has seeded countless tales in books, films, and art. These stories blur the line between knowledge and imagination, reflecting our deepest hopes and our darkest fears. One of the most enduring examples is Carl Sagan's Contact, a novel later adapted into a film. At its heart lies a message from an alien intelligence, not an invasion fleet or a cosmic weapon, but an invitation to conversation. The narrative captures the exhilaration and unease of receiving something that undeniably comes from beyond Earth. In Contact, science becomes a bridge between species, a hopeful vision that emphasizes curiosity and unity over fear. Yet even here, woven into the optimism, is the quiet terror of the unknown. If someone can send a message across the stars, what else are they capable of? Contrast this with Arrival, a film that explores not only the mechanics of deciphering alien communication, but also the psychological and philosophical consequences. The extraterrestrial visitors do not come bearing weapons or demands. Instead, they offer a language that reshapes human perception of time. The story suggests that communication is not just about exchanging information, but about altering consciousness itself. In doing so, it frames the signal not merely as a puzzle to be solved, but as a transformative force that changes what it means to be human. This theme reflects a recurring undercurrent in science fiction, the idea that the first message we receive from the cosmos might not be a threat or even a conversation, but a mirror showing us new dimensions of ourselves. Of course, not all narratives lean toward hope. In works like War of the Worlds or more modern interpretations like Independence Day, signals from space become harbingers of doom. In these stories, the radio crackle from beyond is not a whisper of friendship but the drumbeat of invasion. These tales resonate because they tap into an ancient instinct, the fear that what lies beyond our borders may come not in peace but in conquest. Here, the signal is less a beacon of connection than a warning flare, proof that contact means vulnerability. What ties these diverse stories together is the way they amplify the emotional range of the scientific quest. A scientist pointing a radio telescope at the sky is doing something deeply technical, but in that act, there is also poetry. Fiction translates that poetry into human drama, filling the silence of the universe with imagined voices. The cosmos becomes a stage on which we project our desires for meaning, our dread of annihilation, and our fascination with the other. The signals we invent in fiction are not only about aliens, they are about us, about how we imagine our place in the universe, and what kinds of futures we dare to entertain. The power of these stories lies in their ambiguity. A signal from the stars could be salvation or doom, an invitation or a trap, a gift of knowledge or a weapon of confusion. That uncertainty is what keeps audiences spellbound because it mirrors the uncertainty in real science. Astronomers listen to the cosmos with open minds, but also with caution, knowing that every burst of radio waves could be a pulsar or a galaxy, or improbably something more. Fiction dramatizes this balance, embodying the hope of discovery and the fear of misinterpretation. There is also an aesthetic wonder in the very idea of communication across light years. To imagine that a signal could leave one world, travel for millennia, and finally arrive at another, is to imagine a kind of cosmic storytelling on the grandest scale. Every novel and film that takes up this idea is in some sense an echo of that wonder. When audiences watch a protagonist lean into static-filled headphones, or watch a radar screen flicker with strange pulses, they are participating in the dream of cosmic connection. Even if the story turns toward fear, the premise begins in awe. What is striking is how these fictional explorations often circle back to the same questions scientists ask. If we are not alone, what would that mean for religion, for philosophy, for politics, for everyday life? How would humanity respond, not governments or institutions, but ordinary people, waking up to the news that someone has spoken to us from the rectality stars? Would we unite in wonder or fracture in fear? Would we embrace the invitation or close our ears? Fiction gives us rehearsal spaces for these questions, even as reality remains silent. At times, the influence flows in the opposite direction. Scientific efforts like SETI have inspired art, but art has also inspired science. Young astronomers have admitted that their careers began with reading Contact or watching Arrival. The boundary between what is real and what is imagined is porous. Fiction prepares the ground for discovery, shaping public perception and giving language to possibilities that may one day become fact. The interplay between fiction and science becomes a feedback loop, each nourishing the other. Fear, too, has its role. Stories of hostile aliens or cryptic signals remind us that knowledge always carries risk. The terror of the unknown is not irrational. It is a survival instinct honed over millennia. To ignore that fear would be naive, but to let it dominate would be paralyzing. Fiction allows us to inhabit both sides, to explore what it would mean if the signal meant danger, and then to step back reassured that the danger was only imagined. In this way, storytelling becomes a safe laboratory for existential dread. And yet beneath the thrill and the fear, what lingers is wonder. Even the darkest tales admit in their very construction that the cosmos is worth listening to. Silence is unsettling, precisely because it leaves room for the possibility of an answer. Every invented signal, whether benevolent or malicious, keeps alive the notion that the universe might yet surprise us. And perhaps this is the most profound gift of fiction, that it keeps us curious, that it prevents us from succumbing to despair in the face of silence. For in the end, no story, however elaborate, can outmatch reality. The universe is stranger than any script, more vast than any novel, and more patient than any film. Our stories about signals from the stars reveal as much about us as about the cosmos. They remind us that we are creatures who yearn for connection, who fear isolation, who hunger for meaning. They remind us that the act of listening is itself an act of hope, an assertion that the silence may someday break. And if the real signal ever does arrive, if the static in the headphones resolves into a deliberate pattern, then all the stories we have told will feel like premonitions. But even then, reality will exceed them, because no fiction, however bold, can fully capture what it will mean to truly finally hear a voice, not our own. In that moment, the line between science and story will dissolve, and we will step into a chapter no one has yet imagined. For as much as fiction has stretched our imaginations, the universe always has the power to be stranger, vaster, and more wondrous than anything we can invent. For all the vastness of the search, for all the decades of scanning skies and passing static, humanity returns to the same quiet act, listening. There is a kind of poetry in the persistence. Night after night, observatories turn their great dishes upward. Arrays of antennas stretch like metallic fields across deserts, each one waiting for a whisper that may never come. It is an act of patience that defies the rhythm of our usual lives. A patience measured not in days or years, but in generations. To listen to the cosmos is to admit that the answer might not arrive in your lifetime, or your children's, or even your civilization's, and yet the listening continues. The reason is not only the hope of finding others, but the value of the search itself. Even if the sky never yields a signal, the act of listening changes us. It teaches humility in the face of immensity. It sharpens our imaginations, forcing us to consider what intelligence beyond Earth might look like, how it might think, how it might choose to communicate. It shapes philosophy and art, reminding us that our longing for connection is as fundamental as our need for food or shelter. When a radio telescope sweeps the heavens, it is not only performing science, it is also writing poetry in frequencies, declaring that humanity refuses to be content with silence, without at least asking why. The silence itself becomes meaningful. For some, it is a comfort, a reassurance that perhaps Earth is rare, maybe even unique and therefore precious. For others, it is an ache, the hollow reminder that perhaps we are alone in the dark. And for still others, the silence is a message in itself. If the universe is capable of producing countless civilizations and yet none speak, then perhaps silence is the natural state, or perhaps it is a warning, the echo of dangers that have silenced voices before. Each interpretation reflects not only the cosmos, but our own desires and fears. What makes the listening remarkable is its persistence against uncertainty. In science, we are often rewarded with clear results, proof discovery answers. But in the search for extraterrestrial signals, the reward has so far been the questions themselves. Every time a mysterious pulse is detected, and later explained, we learn something new about pulsars, about fast radio bursts, about the dynamics of the universe itself. Each false alarm enriches our knowledge, even as it denies us the contact we long for. The search then becomes its own justification. We listen not only for the possibility of a reply, but for the certainty that listening broadens our understanding. There is also something profoundly human in the way we listen together. SETI projects often draw volunteers from around the globe, people lending their computer power to sift through data, amateurs contributing to the search alongside professionals. It is one of the few scientific endeavors where the outcome touches everyone, because if a signal is found, it will not belong to a nation or a laboratory. It will belong to all of humanity. In this way, the listening becomes a collective act, one of the rare moments where humanity, fractured in so many ways, points in the same direction. It is also in some sense an act of hope disguised as science. To listen is to believe that there is someone to listen to, that the universe is not indifferent or empty, but waiting to be revealed. This hope endures even in the face of disappointment. It endures because the alternative, that we are alone in an infinite silence, is too heavy for many to bear. In the act of listening, there is defiance, a refusal to accept that loneliness must be our final condition. It is the same defiance that drove explorers to sail across oceans, to climb mountains, to step onto the moon. Listening to the stars is simply the next frontier of that restless spirit, and yet the patience demanded by the cosmos is unlike any patience we have known. Light takes years to travel between stars. Radio waves, no matter how fast, are bound by the same limit. A message sent from a nearby civilization might not reach us until long after the senders are gone. Our reply, if we could manage one, would not reach them for centuries more. To listen, then, is to accept that communication, if it happens at all, may span gulfs so vast that it can barely be called conversation. It is not dialogue, but echo, not correspondence, but resonance. Still, humanity leans in, straining to hear, as if the effort itself brings us closer to the stars. Perhaps the most haunting possibility is that the silence is intentional. Maybe civilizations that survive long enough to send signals also learn that survival depends on quiet. To broadcast one's existence might invite attention best avoided. In that case, the silence we hear is not emptiness, but wisdom, the collective decision of countless unseen others to remain hidden. If so, our listening is not in vain. It is a way of brushing against that collective choice, sensing the outlines of a strategy we do not yet understand. And then there is the possibility that one day the silence will break. That in the midst of static and natural noise, a pattern will emerge, unmistakably artificial, carrying with it the certainty that we are not alone. The waiting would then transform in an instant from speculation to history, from patience to revelation. Until that day, though, we live suspended between silence and possibility, each scan of the sky both another disappointment and another chance. In truth, we do not know what the universe holds. We do not know if it teems with life, or if Earth is a solitary outpost. What we know is that listening keeps us honest. It forces us to confront both outcomes, the loneliness of being unique and the awe of being one among many. Each outcome demands humility. To be alone means carrying the weight of consciousness in a cosmos otherwise silent. To be one among many means accepting that we are not the pinnacle, merely a small voice in a chorus. Both possibilities shift the way we see ourselves. So humanity keeps listening not because we are guaranteed an answer, but because listening is a way of living with the question. It is the act of refusing to let silence be the end of the story. It is a ritual of curiosity, a daily gesture of hope that someday, somewhere, the universe will whisper back. And if that whisper never comes, if silence remains the only reply, then the silence itself will have been a teacher reminding us of our fragility, our persistence, and our yearning for connection. So what do you think? Is there someone out there sending signals into the night, waiting for us to finally tune in? Or is the universe, for all its grandeur, simply an empty stage where we are both the actors and the audience? The answer may never come. But the act of asking is already a kind of dialogue with the stars, with ourselves, with the mystery that binds us to the infinite sky.